In this lesson, we'll create a static simulation study. After completing this lesson, you'll be able to create a static simulation study and set study materials. In this lesson, we want to start creating a structural analysis of our design. Now, this is going to require us to do a few things. If you want to carry on with your file from the previous example, the main differences between this file and yours are going to be the fact that the battery or component case is now made a nylon 6 material, just like the rest of the body. And I also went in and I renamed my sketches so that they had more meaningful names. If you want to continue on with your file, it's perfectly fine, but if you want to upload a version of the file, make sure you navigate to your dataset and upload the XStar C04 Week 2 Lesson 1 F3Z file. I do want to make a note that when we upload an F3Z file, it's going to contain all the distributed design components, such as the motors, the batteries, the flight controller, and so on. One issue with this is the fact that the F3Z file name is not going to be the same as our design. So in this case, when you upload the F3Z file, you will get an XStar version 35 file name. Now in my case, I have XStar V35 V21, and that's because V35 was the version that we brought in from the designer, and V21 is the version that we ended up with at the end of week 1 in the engineering section. Now at any point in time, we can right click and we can rename this file. So I'm going to call this XStar C04-week 2-lesson 1. This is going to be the starting point for our course 4 week 2 lesson 1, where we get into creating our simulations. So with that taken care of, we now want to take a look at how we can simulate this. This is going to be an interesting case because we're dealing with a 3D printed nylon, but we're going to use that nylon 6 material to get as close as possible. And really what we're focusing on is the fact that we have all of these channels of this I-beam structure. We want to make sure that the load from the force of the motors or the lift is actually going to transmit into the center of the body where we have more structure. So we're going to start by going to the model dropdown and enter the simulation workspace. We're going to be taking a look at a static stress analysis, and we're going to say OK. Now when we come in here, you might get a warning in the bottom right corner that tells you that some components have interference. Now this is okay because really what it's telling us is that components potentially like the propeller and motors have interference, or some of our components in the component tray might be touching some of the plastic. So again, that's okay because we're not analyzing those components. We want to get started by looking at the model components folder, and notice that each of these we have the model components. We're not going to be analyzing the motors, the power distribution board, the batteries, or the receiver, or any of the ESCs, or the flight controller. So this is only going to leave us with the XStar component. Now if we expand that, inside of the bodies folder, you can see that we're not analyzing any surface bodies because they are empty shells and we actually need solid elements. We have the XStar body and the component tray. So we're going to be analyzing these two bodies. Now at the top of our screen in the solve section, you'll notice that we have a red X, and this tells us that we're not quite to the point where we can analyze this design. Once this has a green check mark, that means that it has all the required information to solve the study. The first step in our study process, after we've already selected that we're going to do a static stress analysis, and we've gone through and we've hidden all the other bodies that we don't want to analyze, is generally you want to simplify the model. Now in most cases you'll go through and you'll simplify things like fillets that don't necessarily need to be in the model, certain geometry, certain things that you want to remove or omit. Now in our case, I'm actually going to analyze everything. I want to see how the load is affected in the area of our generative design. I want to see how it handles coming into these corners, and I don't want to make any sharp corners because those are going to be bad for us. Now we do have a few areas where we have sharp corners, and these will be addressed as soon as we add the camera mount to the front as well as the video transmitter to the rear. Now the reason that I've left those as is for now is because I know I'm going to have to add geometry and potentially take these ribs away anyways. So the sharp corners there will help that later on. So the first step now is to go to the material dropdown and take a look at study materials. Now you notice that by default everything comes in as steel with the exception of the two components that we set to nylon 6. That's the X-star body and the component tray. Now we have them set to same as model, and the safety factor is based on yield strength. Now this is again an interesting case because we're dealing with not only plastic, but 3D printed plastic. Now, an SLS nylon 3D print is not going to perform exactly the same as something that's machined out of nylon. But for the most part, we're going to use those because, again, the main thing that we're focusing on is how the load is transmitted from the motors to the rest of the frame. This will help us understand if we need to add additional structure in areas such as this point here and attach the component tray to it to add a bit of additional structure. Once you have all the extra bodies hidden and you make sure that the material of both components is nylon 6, let's go ahead and save the file so we can move on to the next step.